Welcome to AI for GIs, Introduction to Artificial Intelligence. This is Module 3, AI and Military Decision Making. Class 12, Data Literacy for Military Leaders. Here's the modern commander's paradox. You have access to more data than any previous generation of military leaders. Satellite imagery, drone feeds, signals intelligence, logistics tracking, predictive analytics. Yet making effective decisions has become harder, not easier. More data doesn't automatically mean better decisions. Without data literacy, this abundance actually degrades decision quality by overwhelming commanders and staffs with noise that obscures the signal. This class examines the four-stage progression from data to understanding, the A2T2P framework for evaluating data quality, the critical gap between warfighters and data professionals, AI/ML limitations that require human oversight, and strategies for prioritizing relevance over volume to prevent paralysis by analysis. By the end, you will know how to systematically evaluate data quality using 5 practical criteria. Understand where AI can assist versus where human judgment remains essential. Bridge communication gaps with data professionals using decision-centric approaches, and maintain critical thinking skills while leveraging AI as an augmentation tool rather than becoming over-reliant on systems with inherent limitations. I'm Dr. T. Justin Webb. Let's begin. So what drives the staff crazy? Unprecedented data access from every domain, but no unified way to make sense of it all. Modern military operations generate data volumes that would have seemed impossible a generation ago. Logistics systems track every piece of equipment. Operation centers monitor real-time positions. Intelligence feeds process signals from multiple domains simultaneously. The challenge isn't getting more data. It's consolidating disparate data into a unified presentation, what we call a single pane of glass, that allows commanders to rapidly assess situations without being overwhelmed by disconnected information streams. Here's the critical insight. Raw data volume doesn't automatically translate to better decisions. Data abundance without literacy can actually degrade decision-making quality. You need the ability to evaluate data quality, understand AI system capabilities and limitations, and focus on relevant information. This is why data literacy isn't a technical specialty for subordinates. It's a core leadership competency for commanders at every echelon. This class develops 5 interconnected competencies that build on each other. First, master the 4-stage progression from raw data to actionable understanding. This framework shows exactly where human judgment becomes essential and where AI can assist. Second, apply the A2T2P framework to assess data quality and operational suitability. 5 criteria: accurate, available, timely, transmittable, processable, give you a systematic way to evaluate any data source. Third, bridge communication gaps between data professionals and military operators. These two communities speak different languages, and that gap costs time and degrades effectiveness. Fourth, integrate AI/ML technologies while maintaining human oversight and verification. AI augments decision-making. It doesn't replace the commander's judgment. Fifth, prioritize data relevance over volume in decision-making processes. Quality trumps quantity when lives are on the line. These aren't isolated skills. They work together to enable decision dominance in data-driven operations. Let me be direct. Data literacy is not optional. It's a strategic imperative. Why does this matter right now? Near-peer competitors are investing heavily in AI capabilities. China's developing robotic systems and data integration platforms. Russia's pursuing AI-driven defensive systems, electronic warfare, cyber warfare, and disinformation campaigns. The side that more effectively turns data into decision-enabling knowledge will possess significant operational advantages. Data literacy enables information advantage, the ability to collect, process, and act on data faster than adversaries. That information advantage directly enables decision dominance in military operations. But achieving this advantage requires synchronized understanding between data professionals and warfighters at all echelons. Your data exploitation capabilities must align with operational tempo and commander requirements for maintaining initiative over adversaries. Here's the critical shift. Required decisions should drive data collection priorities, not the reverse. Don't collect available data and then determine what decisions you can make. Identify required decisions first. Then, specify what data will inform those decisions. This decision-centric approach ensures your data efforts directly support operational needs, rather than overwhelming staffs with irrelevant information. Let me show you the four-stage cognitive progression that structures military decision-making. Data becomes information through contextualization. Information becomes knowledge through analysis and synthesis. Knowledge becomes understanding when integrated with experience and judgment. This progression shows exactly where commanders and analysts add value. Here's a tactical example that brings this to life. An unmanned aerial system captures thermal imagery showing heat signatures in a specific grid square. That's raw data. When an analyst correlates this data with mapped terrain features and timestamps, identifying 3 vehicle-sized heat signatures moving north on Route Jade at 0430, it becomes information. When the intelligence officer combines this information with known enemy tactics, recent pattern analysis, and mission variables to assess likely enemy logistics convoy supporting defensive preparations, it becomes knowledge. Finally, when the commander integrates this knowledge with the mission, enemy situation, terrain, available forces, and time considerations to decide we will interdict this convoy with indirect fires at grid NV12356, it becomes understanding that drives action. Here's what matters. Confusion at any stage undermines decision quality. Skipping stages creates cognitive overload. Now let's complete the progression and see where human judgment becomes essential. Knowledge becomes understanding through integration with experience, judgment, and commander's intent. In our tactical example, the commander's decision to interdict that convoy with indirect fires represents understanding, operational art applied to knowledge. So what is the critical distinction for military leaders? AI excels at data processing and pattern identification. That's stages 1 and 2, data to information, information to knowledge. AI can handle massive volumes, identify patterns humans would miss, and process faster than any human analyst. But the leap to understanding, where operational art, mission command principles, and commander's intent shape decisions, requires human cognition that integrates factors AI systems cannot adequately model. This is stage 4. Commanders who understand this progression can structure their staffs and AI tools to handle appropriate stages, while preserving human decision-making authority where it matters most. This framework also helps diagnose operational failures. When operations go wrong, asking, did we have bad data? Did we misinterpret information? Did we synthesize knowledge incorrectly? Or did we fail to achieve understanding? Helps identify where the breakdown occurred and how to prevent similar failures. Let me give you a practical tool for evaluating data quality. The A2T2P framework provides 5 essential criteria that work for any data source. Accurate means trustworthy and correct data from reliable sources. Available means accessible when needed for decision-making. Timely means current and relevant to the operational situation. Transmittable means shareable across systems and networks, even in degraded communications environments. Processable means analyzable with your existing tools and capabilities. Here's why this matters. Each dimension represents a potential failure point. Accuracy failures occur when sensors malfunction or human observers misidentify targets. Availability failures occur when critical data exists but cannot be accessed by decision makers who need it, locked in classification compartments or trapped in incompatible systems. Timeliness failures occur when data arrives after the decision window has closed. Transmittability failures are particularly acute in denied environments, where even small data packets struggle to move across degraded networks. Processability failures occur when data format or volume exceeds your unit's capability to analyze it within operational timelines. The framework provides a common language for data quality discussions between commanders and data professionals. Rather than vague requests for better data, you can specifically articulate requirements using A2T2P criteria. Let me show you how the A2T2P framework solves real operational problems. Each dimension represents a failure point, from sensor malfunctions to incompatible systems. By systematically checking all 5 criteria, you catch problems before they undermine decisions. The framework provides common language between commanders and data professionals for specific requirements. Instead of saying we need better data, you can say we need data that is updated every 6 hours, timely, can be transmitted over our current SATCOM bandwidth, transmittable, and can be visualized using our existing map displays, processable. That precision helps data professionals understand requirements and propose solutions that actually address operational needs. Here's the cultural shift this enables. From collect everything to collect what matters. Quality over quantity. Teaching leaders early in their careers to prioritize relevant, actionable data over comprehensive but unprocessed volumes improves staff work efficiency and decision-making effectiveness. The framework also addresses big data era challenges. Leaders must develop capabilities to discern signal from noise, manage cognitive load from information overload, and establish filtering mechanisms that preserve decision speed while maintaining analytical rigor. Now, this is the cultural shift military leaders must embrace. From collect everything to collect what matters. The explosion of available data creates challenges beyond traditional information processing. Leaders must develop capabilities to discern signal from noise, manage cognitive load from information overload, and establish filtering mechanisms that preserve decision speed while maintaining analytical rigor. Understanding these big data era challenges helps commanders structure staffs and processes to exploit data volume without being paralyzed by it. Quality trumps quantity in military data utilization. Teaching leaders early in their careers to prioritize relevant, actionable data over comprehensive but unprocessed volumes improves staff work efficiency and decision-making effectiveness. This prevents data overload and focuses analytical efforts on information that directly supports commander requirements. The A2T2P framework provides common language between commanders and data professionals for articulating specific requirements. Instead of saying, we need better data, you can say, we need data that is updated every 6 hours, timely, can be transmitted over our current SATCOM bandwidth, transmittable, and can be visualized using our existing map displays, processable. That precision helps data professionals understand requirements and propose solutions that actually address operational needs. Preventing paralysis by analysis requires this disciplined approach. Without it, decision hesitancy emerges as commanders wait for more data. Staff processing becomes desynchronized, and cognitive overload degrades decision-making quality. Let's talk about what AI actually can and cannot do. This is critical for military applications. AI and machine learning systems operate within defined parameter sets that constrain their analytical capabilities. When confronted with scenarios beyond their training parameters, especially novel tactical situations or adversarial adaptations, AI/ML outputs become unreliable. Poor data quality represents a fundamental AI trustworthiness risk. When training data doesn't accurately represent operational contexts, contains biases, or becomes outdated relative to deployment environments, AI system reliability degrades. Military leaders must understand that even sophisticated AI models cannot overcome fundamental data quality problems. LLM hallucinations result from imitative falsehoods. When models memorize and reproduce misinformation, fake news, and unfounded rumors present in training data sets. Garbage data input during training creates unreliable outputs during operation. This is why data quality control is a strategic concern when deploying AI systems for military decision support. Foundation models require rigorous data quality management due to their scale and complexity. Training data can contain biases, poisoned information, duplicates, and false content. Here's what matters. Larger models amplify data quality problems rather than overcome them. Think about that. Bigger AI doesn't fix bad data, it magnifies the problems. This is why data validation and quality control are strategic leadership concerns, not just technical issues. Military leaders must understand that this is not a technical problem for data professionals to solve alone. Data quality is a command responsibility that directly impacts mission effectiveness. Here's a critical distinction. Human-in-the-loop verification is not an optional enhancement. It's an essential risk control. AI systems require human oversight as a critical risk control. Commanders need literacy in AI capabilities and limitations to know when AI recommendations are trustworthy versus when human judgment must override system outputs. This understanding enables effective human-machine teaming, where humans provide context, ethical judgment, and operational insight that AI lacks. Continuous human-in-the-loop verification is required for novel tactical situations beyond AI training parameters. When AI encounters scenarios it wasn't trained for, adversarial adaptations, unexpected tactical situations, commanders and analysts must validate AI conclusions against operational reality and doctrinal principles. Large language models function most effectively as human operator aids rather than autonomous decision makers. Military applications require human expertise for quality control, preventing overconfidence in LLM outputs, and maintaining operational effectiveness. Leaders must understand that LLMs lack genuine comprehension and require continuous human oversight, especially for real-time military operations where latency and AI limitations render fully autonomous LLM employment inadvisable. While large language models demonstrate impressive text generation capabilities, military leaders must understand their fundamental cognitive limitations. LLMs cannot truly reason or plan, despite producing outputs that appear thoughtful. They generate responses that mimic human-like reasoning without engaging in actual cognitive processes. That creates a critical distinction between appearing intelligent and possessing genuine understanding, especially important when these systems inform high-stakes military decisions. AI functions best as aid to human operators, not autonomous decision-makers in high-stakes contexts. Let me show you where the system breaks down most frequently: the gap between warfighters and data professionals. There's a fundamental gap between warfighters with operational needs and data professionals with technical skills. Warfighters often struggle to articulate data requirements in technical terms. Data professionals lack operational context to prioritize efforts. This miscommunication results in ineffective data products that fail operational requirements. Here's a concrete example. A data scientist spent 1 week building a machine learning model that predicted enemy activity patterns with high statistical confidence based on historical data. Technically excellent, rigorous methodology, solid validation metrics, clear uncertainty quantification. But the model was trained on pre-conflict data, and the enemy had fundamentally changed tactics since hostilities began. The product was operationally useless. The data professional, lacking tactical experience, didn't realize the operational environment had invalidated the model's assumptions. The inverse problem. A battalion commander requested 72 hours of enemy vehicle movement data. The data professional dutifully provided everything, terabytes of raw sensor feeds requiring days to process. What the commander actually needed was a simple pattern analysis answering where is the enemy positioning logistics assets to support defensive operations. The A2T2P framework and decision-centric approach provide common language for alignment. Build shared understanding through sustained interaction, cross-functional collaboration, and training that develops both communities. Here's the key to avoiding information overload. Let required decisions drive data collection priorities. Commanders' Critical Information Requirements, CCIR, function as focused data collection guidance that prevents information overload. Well-crafted CCIR statements direct staff efforts toward gathering specific, actionable data that directly supports decision points, rather than attempting comprehensive but unfocused data collection. The decision-centric approach works like this. Identify required decisions first, then specify what data will inform those decisions. This prevents the collect-everything approach that leads to information overload and avoids paralysis by analysis from excessive data without decision focus. When data collection efforts lack focus and discipline, paralysis by analysis emerges as a serious threat to operational tempo. Leaders must recognize the symptoms: decision hesitancy, due to expectation that more data might become available; desynchronized staff processing when data flows bypass necessary analytical steps; and cognitive overload when information volume exceeds processing capacity. These conditions degrade rather than enhance decision-making quality. Synchronize data exploitation capabilities with operational tempo requirements. The pace of data processing must match the pace of operations, or you create bottlenecks that slow decision-making when speed matters most. One thing of note is the risk leaders must actively prevent. Critical thinking skills will atrophy from AI over-reliance. Commanders must maintain manual analytical capabilities, even as AI/ML augments decision-making processes. Over-reliance on automated analytics without continuous human validation causes critical thinking skills to atrophy, compromising the commander's ability to conduct analysis when AI systems fail or when facing novel situations outside AI training parameters. AI/ML is a tool, not a substitute for command judgment. This skill atrophy risk is real and dangerous. Consider an S2 who relies entirely on AI-generated intelligence summaries without conducting independent analysis. When the AI system fails, due to communications loss, adversary jamming, or encountering situations outside its training parameters, that analyst has lost the ability to manually process intelligence and provide the commander with assessments. If personnel do not remain engaged in the consistent process of validating and verifying data analytics, the ability for personnel to conduct analysis and make assessments will rapidly be diminished. The evolution of data analytics must not become synonymous with compromising the commander's ability to make decisions. AI/ML solutions cannot be misconstrued as authoritative or a substitute for the commander's ability to employ the art and science of war. Leaders must establish training programs and operational practices that keep human analytical skills sharp. Practical approaches include conducting regular unplugged exercises where units operate without AI support to maintain manual planning and analysis capabilities, requiring staff officers to explain AI recommendations in their own words and validate outputs against doctrinal principles before presenting to commanders, rotating personnel between AI-assisted and manual analysis roles to prevent over-specialization, and incorporating AI failure scenarios into training exercises so units learn to recognize and respond when AI systems provide unreliable outputs. The goal is not to avoid using AI. Its capabilities provide genuine advantages, but to ensure organizations can function effectively when AI systems are unavailable, unreliable, or operating outside their design parameters. Leaders who maintain this balance position their units to exploit AI advantages while avoiding dangerous dependencies that create vulnerabilities adversaries might exploit through jamming, cyber attack, or tactics specifically designed to confuse AI systems. The bottom line: we're operating in an era of information abundance and AI-augmented warfare that demands new leadership competencies. Data literacy is a strategic imperative for all military commanders, not just technical specialists. Information advantage depends on transforming data into understanding faster than adversaries. Use decision-centric approaches like CCIR, quality frameworks like A2T2P, and cognitive models like the data to understanding progression. Maintain human-in-the-loop verification and manual analytical skills as adversaries develop parallel AI capabilities. Don't let AI systems atrophy the very capabilities that make you effective when those systems fail or face novel situations outside their training parameters. Decision dominance is achieved through data literacy, not data volume. The commander who can turn relevant data into understanding faster than the adversary wins. Military leaders who develop data literacy will be better positioned to employ AI/ML tools effectively, maintain appropriate skepticism about automated recommendations, and preserve the human judgment that remains essential for successful military operations. This literacy is not optional. It is a strategic requirement for maintaining decision superiority in an increasingly data-driven operational environment. I'm Dr. T. Justin Webb. Follow me for daily AI insights for military professionals. Find the full course below.